Hello, good morning. I am Katkaratish, Assistant Professor in Engineering College, Halawar. This is my second lecture. In this lecture, we are going to focus on the next supervised approach, that is support vector machines. So, basically, the objective of this topic is we have to find out that hyperplane which maximizes our criteria, it maximizes the margin between two classes. In this, we are going to see the contents basic terminologies. In these basic terminologies, we will see what is machine learning and the types of machine learning. In introduction, we are focusing on the SVM part. It is mostly the topics that will be useful in SVM. Then important concept related to SVM. Then the most important part is the kernels, because kernels plays an vital role in SVM. Then which are the different types of kernels used in SVM? Basically, this SVM will take 4 to 5 lectures to cover. So in this first lecture, we are focusing on the main terminologies, that is basic, which will be useful in next lecture. So first, what is this machine learning? This is the definition of machine learning by Tom Mitchell. According to him, a computer program is said to be learned from experience that is available with us with respect to some class of task. The task may be any classification or any regression, anything, and we have performance measure like recall, uh, accuracy. If its performance at task T, whatever the task T, if performance as measured by P improves with experience, if performance is improving with the experience E, then we can say that the program is learning. So next is, there are two types of machine learning basically. Normally we consider three types, that is the third one is reinforcement learning, but in mostly books it is given that there are two types. So first is supervised learning. In this learning, we are given with the labels along with the instances, input instances. So means we have given with the actual output. In this, so some supervised learning methods are NAS neighbors, neighbor-based support vector machines, decision trees are the supervised learning algorithms. Earlier we have seen that k-nearest neighbor and neighbor-based. In this lecture, we are focusing on SVM. And second type of learning methods are unsupervised learning methods. In this, the labels are not given with us, only input instances are given. In this, K means clustering problem will come, then PCA will come, then singular value decomposition, etc. Are the unsupervised learning. That also we are going to focus, but that will take time. So in this lecture, we are basically focusing on SVM. So we will start with SVM. Yeah, basically SVM is used for classification and regression tasks, but in our case we are focusing on classification tasks. So a classifier derived from statistic learning theory by Wapnick and all others in 1992. The next is support vector machines can be used for perform any level of classification. What do you mean by this? Any level of classification means it is applicable to two or more classes and also linear and non-linear data set. SVMs are designed to provide adaptable approach to decision boundaries between two classes. Actually, it will find out the adaptable, actually best decision boundary, because we are focusing on the maximization criteria in this, so we can able to find the optimal separation between two classes. SVM is widely used for text recognition, then content-based image retrieval, speech recognition, object detection, and many others, and many others. Okay. So the next is the important concepts that are useful in SVM. First one is support vectors, hyperplane, and margin. What is meant by support vector? The support vectors are the training samples that define the optimal separating hyperplane and are the most difficult patterns to classify. Okay, so in this diagram you can see that this green dot and this these are considered as, sorry, this these are considered as support vectors that are difficult to classify. According to these support vectors, we are able to find out the hyperplane. And what is this? This is the misclassification example. This is also a misclassification example. Next, hyperplane. It is a decision plane or space which is divided between a set of objects having different classes. See, this is the hyperplane. We can say that it is separately dividing the two classes in best way manner. And margin, it may be defined as gap between two lines on the closest data points of different classes. See, this is the margin. With the help of support vectors, we have found out the margin. This figure illustration shows that how optimal separating hyperplane is found out. The next concept is used in SVM is kernel tip. SVM uses a technique called kernel tip to transform your data, and then based on this transformation it finds an optimal boundary between the possible outcomes. So transform your data means actually it transforms lower dimensional data to higher dimensional data. For this transformation, we are using some kernels that we are going to see in next slide. So next is how to find out the maximum margin hyperplane. First, SVM will separate hyperplanes iteratively that segregates the classes in best way. Segregate means that separate the classes in best way, and then with the help of that, those from those hyperplanes we will find out that hyperplane which separate the classes correctly. Okay, so why we need kernels? Kernels are used because you can see that this is an data set distribution where two classes data are given, that is red classes and another is blue classes. You can see that the mm, the boundary or hyperplane is not linear in this. So my question is that can you try to solve the above problem linearly? No, it is not possible. We cannot find out the linear boundary between them. So because the data is randomly distributed, so in machine learning a kernel is used to refer the kernel tip. Method of using linear classifier to solve the nonlinear problem. This is a nonlinear problem, so kernel tip gives us the way to find out the boundary for this nonlinear problem in linear way. So there are some kernels available with SVM. First is linear kernel. Basically, it is used as a dot product between any two observations. Suppose x1 and x2 are two observations or instances are given, then we can find out the dot product between them. That is the linear kernel. So the detail about this we will see in next lecture. Then next is a polynomial kernel. It is more generalized form of linear kernel and distinguished curved or non-linear input space. And next is radial based kernel. Actually, this is the most important kernel used in SVM. It maps input space in indefinite dimensional space.